We're on 6.01 for PreCalc today, and we're going to talk about law of sines and area of a triangle. So you guys should have seen law of sines before in geometry. So law of sines, the formula is not too bad to remember. It's just the side length A over sine of the angle opposite it equals B over sine of angle B equals C over sine of angle C. And you only need 2 out of those 3 fractions to work with at a time. Other notes here, you want to use law of sines to find sides or angles of an oblique triangle. So it's not a right triangle, it's an oblique triangle. For right triangles, you can use Pythagorean theorem and SOHCAHTOA, your right triangle trig. Now, this can be used on right triangles as well. But since we have those other options, we sometimes use those instead. In order to use law of sines, you need to know a side and the angle across from it. If you know that, then that's a good indication that you should use law of sines. All right. Now let's do some problems. So in triangle ABC, we're given that capital C. So remember, capital letters are angles, lowercase letters represent sides. So capital C, so that's angle C is 103 degrees. B is 28 degrees. Lowercase b is 26. And find lowercase a to the nearest tenth. So usually it helps to draw a picture. Again, it doesn't have to be to scale, just so that you can get an idea of what information you have and what information you still need. So B is 28. Lowercase b, so that's across from angle B, is 26. And we want to find A. So first of all, I recognize that I know I have angle B and side B. So when I have a side opposite an angle, both given to me, I can use law of sines. All right, but I want to find side A. So what I can do is I need to know more information here, because if I normally set up law of sines, I do 26 over sine of 28 equals side C over sine of 103, but that would give me side C. I want side A. So I need to know angle A across from it. Well, I have a triangle, so I'm just going to subtract the 103 and 28 from 180. So 180 minus 103 minus 28, and that gives me 49. So now I know that angle A is 49 degrees. Now I'm going to set up my law of sines. So I'm going to do 26, which is B. So I'm setting up B over sine of angle B equals A, because I'm looking for A, over sine of angle A. So that's the 2 out of the 3 that I'm choosing. So 26 over sine is always sine of the angle, so sine of 28 degrees equals side A, I don't know yet, over sine 49 degrees. All right, once we have that, it's really just a matter of cross multiplication. And of course, writing out your work. So always make sure the 26 goes in front of, so the side length goes in front of sine, equals A times sine of 28. And to solve for A, I'm just going to divide by sine of 28. So now I'll go to my calculator. In your calculator, because of the givens are all in degrees, you want to make sure your calculator is in degree mode. Very, very, very important. So now I have 26 times sine of 49 degrees. And I'm going to divide that by sine of 28. So write out our entire decimal here, but that decimal is also rounded. That's why I used approximation symbol there, 41.79688535. And this said to round to the nearest tenth, which would be 41.8 for side A. And that's our law of sines. Now, law of sines can get harder with what we call the ambiguous case. And the ambiguous case occurs when you know two sides and an angle that's not included between them. That's your donkey theorem from geometry. And this is the reason why you're not allowed to use that to get triangles to be congruent, because it doesn't always work. Sometimes there's 0 answers, sometimes there's 1 answer, and sometimes there's 2 answers, meaning sometimes there's no triangles that can come from what we're given. Sometimes there's only 1, and sometimes there's 2 different triangles that we could get. So in this one, let's see which of those 3 cases we have. So in triangle ABC, lowercase a is 15, lowercase b is 25, capital A is 85. Remember, lowercase letters are sides, uppercase are angles. So here you can see I'm given 2 sides and 1 angle. Determine which of the 3 types of answers, so meaning 0, 1, or 2, this ambiguous case results in. So to do that, to figure out if we have how many solutions, 0, 1, or 2, first start out by drawing a picture. So we've got triangle ABC, and we're going to label what we know so far. So lowercase a, so that's side A, which is across from angle A. So that's 15. Lowercase b is across from angle B is 25. And capital A, which is angle A, is 85 degrees. So first of all, I notice I know side A and I know angle A. So I have a side across from a given angle, which means I can use law of sines. So let's set it up and start to solve. It doesn't say anything we're specifically supposed to solve in, so we'll just start solving what we can find. So 15 over sine of 85 equals 25 is the only other side we know, and that's across from angle B. So sine of angle B. So the ambiguous case here is going to happen when we're looking for a missing angle. So now, just like before, we're going to cross multiply, write the number out in front of the sign. So 25 sine 85 equals 15 times sine of capital B. Divide both sides by 15 to isolate our sine. And go ahead, take a moment, pause the video, and type this side right here into your calculator and get your decimal. 25 sine 85 divided by 15. Oops, I only divided by 15 once. I did push it an extra time. So it should be 1.660324497. Now, if I were to use my calculator and do second sine. So whenever I'm looking for an angle, Remember, you're going to hit second sine, second cosine, second tan. Those inverse trig functions, that's what finds an angle, not a side, but an angle. And then I'm going to scroll up and grab the correct answer. It's right here. And uh-oh, what happened? It gave me an error. Okay, so why did it give us an error? Well, sine is equal to a number bigger than 1. We can never have sine or cosine bigger than 1 because that would tell us that your hypotenuse when you're talking about a right triangle, the hypotenuse is bigger than one of the side lengths. So it can never be bigger than 1 or less than -1. So that gives you an error, which means there are no triangles possible. So 0 would be your answer. 0 triangles. So that one's pretty quick to do because there's no triangles. The next one is much longer to do. So for number 3, we're given triangle ABC. Side A is 12, side B is 31, and side A is angle A, is 20.5 degrees. Determine how many possible triangles there are. We can round to the nearest tenth where appropriate. And I want you to find and solve all triangles. Okay, so first let's draw out what we have. Triangle ABC, side A is 12, side B is 31, and angle A is 20.5 degrees. So I notice here I have side A and angle A, so I have a side across from a given angle, which means I can use law of sines. So again, we're trying to solve all the triangles, so let's just start by doing what we can. So we'll take side A over sine of angle A, set that equal to, the only other thing we know is side B, so we'll take side B over sine of angle B. So now I'm looking for angle B, and I'm going to cross multiply. So I get 31 times the sine of 20.5 equals 12 times the sine of angle B. Divide both sides by 12 and type this whole side into your calculator. Pause the video, go ahead and do that right now. All right, so you should have gotten 0.90470240016. And I'm looking for an angle here because it's always sine, cosine, tangent of an angle. So to find angle B, I'm always going to use the inverse trig function. So I'm going to do inverse sine of that answer. And you're going to type that right into your calculator. Pause the video, type that in. And you should get 64.783231334. Okay, but whenever we're looking for an angle, we always have potentially two possible angles. So first we need to figure out what quadrants we could possibly be in here. So sine of B is equal to a positive number. So where is sine positive? Because sine B equals positive 0.9. All right, so it's positive in 1 and 2. So now let's talk about our reference angle. Is this angle acute? Yes. Is it positive? Yes. So, and it's formed with the x-axis? Yes. So that's going to be our reference angle. It's already acute, so we don't need to do anything to find our reference angle. So we already know what it's going to be in quadrant 1, since 64.7 degrees is in quadrant 1. So we can approximate to the nearest tenth here, 64.8 degrees. Now we also want to find it in quadrant 2. So to find it in quadrant 2, we would take 180 minus that whole decimal. And that should give you 115.216768. And again, we can round now to the nearest tenth, 115.2 degrees. So right here, I want to stop and just kind of look at what we have so far. So we have now used law of sines to find angle B, and we've got there to be two different answers, 64.8 and 115.2. So we need to decide, are both of these possible angles for angle B? Those are both for the same angle, angle B. All right, so to decide that, you want to look at your original triangle. This is always what students usually struggle with. So really try to focus here and try to understand what's happening. So I want to know, will both of these work? So first, for angle B, I have an option of 64.8. So if I go to my calculator and I had 64.8 plus the angle that's already there for A, which is 20.5, I get 85.3. So what you're looking for is that less than 180 degrees? And yes, 85.3 is, so that would work. As long as it's less than 180 degrees, you'll have room for a third angle. Let's check 115.2 now. So I'll take 115.2, and obviously I'm just using rounded values to see if these would work. Is that under 180 degrees? Yes, so they both work, which means if they both work, I have two different triangles. Because when added to angle A, which is 20.5, both give sums less than 180 degrees. Therefore, that tells us we have, it's the therefore symbol, I don't know why it's connecting the dots, two triangles possible. Okay, so if I just asked you how many possible triangles, you would be done, because you can now tell both of these angles work. There's two triangles. If only one of them worked, so let's say angle B here, in quadrant 2, caused our triangle to be, when we added it to 20.5, it gave us 190 degrees. Well, then we would have no room for a third angle, so we would reject that one, and we would have only one triangle then possible. So it all depends right here if you keep 1, 2, or none. If they both have to get rejected, then there would be 0 triangles. If one gets rejected and you keep one, there's one possible triangle. And if both of them work, like in this case, we have 2 possible triangles. So now I asked you guys to solve those triangles. So you have 2 different options for the triangles. So we're going to draw those out over here. So option 1 and option 2. So I'm going to redraw this triangle for A, B, C. Now, the given information in the original problem, none of that is ever going to change. That has to be true for any possible triangle that we have. So I'm going to put that all in red. So that's 20.5 for angle A, 12, and 31. 12, 31, and 20.5. So all of that's exactly the same for both of these. All right, so now in option 1, angle B, let's do the quadrant 1 angle, could be 64.8. In option 2, angle B could be 100 and too close there. 115.2. So those are the two different angles we just got from that first part here. So those are creating two different triangles. Now I want you to solve each of these triangles. So this is a very long problem. So now I'm going to find angle C. So to find angle C, I can just, this one in purple, subtract my other two angles. So subtract the 64.8 and subtract the 20.5. Now you should be using those long decimals as well, which you can grab from your calculator or you can type them all out. So 180 minus 20.5, that one we know is a short decimal, minus, I'm going to go up here. Oh, I actually didn't put that one in my calculator. So I'm just going to type out the long decimal. So 64.7, you guys should have it already in your calculator, so you can go ahead and just grab it. 3, 2, 3, 1, 3, 4. And we'll write out that whole decimal, and then we'll round it. So make sure you use here 0.78, 3, 2, 3, 1, ... So use the long decimal. All right, and so that gave me approximately 94.71676866. And again, we can round now to the nearest tenth, so 94.7 degrees. So that would be our angle C. So 94.7. So now we're missing just one more side, that's side C. So I'm going to find that one now. So I'll stick with my purple here. So I know it's easiest to use the shortest numbers. So I'm going to stick with 12 over sine of 20.5. And I don't have to worry about long decimals for at least the left-hand side. And then side C is what I'm looking for, lowercase c over sine of 94.71676866. And you should be using that long decimal there. So now pause the video, go ahead, cross multiply there, and solve for C. All right, so again, write out your full decimal. So 34.14936692, which is approximately to the nearest tenth, 34.1, which is side C. And now I've finished solving. I have all three angles, all three sides for option 1. So we're done with that. Now we have to go on to option 2. So we're going to do the exact same thing. So I want you guys to pause the video, but now you're going to do all of that work. So find angle C and side C for option 2 using angle B as 115.216768. Okay, go ahead, pause the video and do that right now. All right, so you should have taken 180 minus your full decimal, 115.216768 minus 20.5, and that should have given you angle C at approximately 44.2832317. Round that to the nearest tenth would be 44.3 degrees. So now we have angle C is 44.3. We have all three angles. We just need to find the third side, which is side C. So again, you're going to do your law of sines. So 12 over sine 20.5 equals your side C over sine of your full angle, cross multiply, write out your long decimal, and then round it to the nearest tenth. I'm going to just check your notes that you guys have written it out and shown all your work. And then you can write out your rounded value of 23.9. So here are your two possible triangles. So there are two triangles possible for this one. All right, so now we're going to talk about finding the area of a triangle. So in order to use our formula, which is K equals 1/2 A times B times sine of C, you have to have, and C is a capital C, you need to have side, angle, side for your triangle. So you need to know two sides and the included angle between them. So let's take a look here. My goodness. 4. Find the exact value. This is not going well with the writing. Find the exact area of triangle ABC if the measure of angle A equals 60 degrees, lowercase c, so side C is 12, and lowercase b is 9. All right, so first I'm going to draw a picture of triangle ABC. A is 60 degrees, side C across from angle C is 12, and side B is 9. So I do have side, angle, side. So the angle I have here is included between the two sides that I know. So now I'm going to use my formula. So K equals 1/2 one of my sides times the other side times sine of the included angle. So 60 degrees. Now this asks for the exact area. So I do not want a decimal or a long decimal irrational number from your calculator. So if you type it in, you'll probably know that notice you get an irrational number. So we want to actually find what sine of 60 is as an exact value. So you might already have that memorized. If you don't, you could draw your table or your 3 lines. So remember, this is rad 3 over 2, 1/2. I'm going to skip 45 for now because I know that one's rad 2 over 2. So here I want to find the sine of 60. So here's 60 degrees. The sine is the second term here. So that is rad 3 over 2. So now I'm going to substitute in rad 3 over 2 in for sine of 60. Now I'm just going to simplify. So half of 12 is 6. So I have 6 times 9. Oh my goodness. So sorry. I'm looking like I'm crossing things off when I'm not. 6 times 9 times rad 3 over 2. I could also reduce that 2 with the 6 to give me a 3. So now I have 3 times 9 is 27. And I have a rad 3 left. So 27 rad 3 would be the exact area. And that would be just your units. Well, that says units squared. All right, let's look at one more. So find the area. Okay, I'm going to try and type this because this is getting really hard to read. Okay, find the area of triangle CLV if the measure of angle, and you can write that in symbols, measure of angle L equals 80 degrees. The measure of angle C equals 65 degrees, and lowercase c equals 17. And round to the nearest tenth. All right, so first let's draw our picture. Try and close some things here. So CLV, so angle L is 80 and C is 65 and side C is 17. So I do not have side angle side here. So I need to get side angle side. In order to do that, I got to see what I can find. So first of all, I see I have 2 out of the 3 angles. So I can pretty easily find my third angle by just subtracting 65 and 80 from 180, and that'll give me 35 degrees. So now I know and put the new information in pink. So 35 degrees is angle V. Okay, now I still don't have side angle side. I need another side. So I either need side L or side V. So in order to find the side, we do not have a right triangle, so we can't use SOHCAHTOA, but we do have a side across from a given angle. So I can use law of sine. So I can do 17 over sine of 65 equals, and let's go ahead and find side L. So let's do lowercase l over sine of 80. Pause the video here, cross multiply, and solve for L. All right, so you should have gotten 18 point, and I'll write out the whole decimal, 472.45719. Now, if I know this is 18.472 dot, 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 now I have side angle side. So I have the side 17, this side L, and the included angle, which is V. So now I'm just going to substitute right in to our formula for the area of a triangle. So we use this formula, I don't think I mentioned at the beginning of this part, that when we can't find our height of a triangle. So normally we do 1/2 base times height, but we can't always find the height very easily, especially in these oblique triangles. So that's why we have this other formula to help us find the area when we don't have enough information to find the height. So now pause the video here, substitute in. Remember to substitute this entire decimal into your formula. And then you're going to type it into your calculator. All right, so you should have all of that work written out. So I should see your substitutions in for L. You should be putting in this whole long decimal. Then you should have had 17 times sine of 35. And then write out your entire decimal there for K. And then round it to the nearest tenth, which would be 90.1. And again, that would be units squared. If you had found the other side, V, that one would have been 10.75881677. And that also would have worked, but you would have used angle 65 instead of the 35 degree angle to get side angle side. But it is possible. All right, and the last part we're going to talk about is something called, another way to find area, but this one is called Heron's formula. And this one would be used if you have side, side, side. So if you know all 3 side lengths, then that will allow you to find the area of the triangle. So what you're going to do is first you would find, we're going to call it S. So that's the perimeter. So we're going to say this is triangle ABC. And then you're going to divide that perimeter by 2. So given triangle ABC, find the perimeter divided by 2. And then in our formula, we're going to take that number, S, and then subtract each side length from it, multiply those all together, and take the square root. So this one's not too hard to remember. Really important is this part, remembering what S is for the formula. So finding the perimeter and dividing it by 2. So let's just do one of these. So find the area of a triangle with sides A equals 43, B equals 53. And of course, they don't have to be called A, B, and C. You would just adapt it to whatever letters you have in the triangle. And C is 72. And let's round to 3 decimal places. I don't know why it's so hard to write. Okay, so first let's find our perimeter and divide that by 2. So we're going to take 43 plus 53 plus 72 and divide all that by 2. So that gives you 168 divided by 2, or 84. Now we're going to substitute in to find our area. So I'm going to take the square root of 84, and then I'm going to take 84 and subtract each side length here. So 84 minus 43, 84 minus 53, and 84 minus 72. Now it's just a matter of typing all that into your calculator. So go ahead and type in everything that's underneath the radical. This way you can get some partial credit if you type something in wrong. And you should get we've got 1,281,168, and then take the square root of that. We have 1,131.88692, and it said to round to 3 decimal places without connecting every number. 1131.887 units squared. All right, so that is how you'd find the area given all 3 sides. The 1/2 AB sine C is if you have 2 sides and an included angle. That's what the formula you would use to find the area there. And the rest is your law of sines. If you have any questions, be sure to let me know, and pi out.